mostly work on restoration engineering and water quality. I have research projects that span agriculture to urban. I can talk to you a little bit about questions you might have about kind of landscape scale processes, as well as microbiology and how we use natural systems to kind of remediate problems that humans have been kind of perpetuating or creating over time. I also work in a lot of spaces related to climate change, so kind of have my research program into a couple different kind of topic areas. But yeah, I think I'll just stop there and let you guys ask questions as they come up. I hope that was enough of an introduction.
Great. So how about Dr. Shah introduces herself, and I'm almost done putting out a chat to everybody.
Great, thanks.
Okay, yes, hi, I'm Amisha Shah, and I am actually in the civil engineering department, but I also have kind of a joint appointment in environmental and ecological engineering, so I'm kind of in two spheres at once. But essentially, I work on water treatment and water quality, and so I'm really interested specifically in how contaminants sort of, degrade and form other things over time, whether it be like a desalination treatment process or a water reuse treatment process, or be it somewhere in the middle of the ocean. It really doesn't matter. I kind of am intrigued by chemical reactions and sort of how they affect water and what goes on there. And so a lot of the projects that I do, they have interesting applications to drinking water treatment, wastewater treatment, and some of these newer ways to capture fresh water. But I also sort of have a little bit of legs in climate change and other environmental areas where I'm trying to sort of link water quality with these larger global problems. But I think all of it's interesting and fascinating, and so it's how you do it, and it's definitely fun to explore all these new areas of science. So I don't know if there's anything else. Yeah, I can let Dr. Welton. Are you ready, or should I? Okay.
Yeah, no, this is great. This is great. So many of you are posting in the chat, which is awesome. So finding out that you're need to delete that video. Okay. And so my name is Andrew Welton. I am an associate professor at Purdue University in civil, environmental, and ecological engineering. Miguel is sharing his screen.
I know. Is there a way to kick these people out?
This will stop. Yes. So
yeah, I'm trying to as soon as they pop up, if they pop up.
I kicked him out, but
sorry about this.
That's fine. So you can take over the share screen option and just don't let it happen. Nobody needs to share the screen.
Yeah, we'll just talk.
Yeah. So I focus on water treatment, water distribution, water quality, disasters, and we do a lot of environmental work where we deal with water, air, and other systems. Now, what a lot of faculty that are not here do is a whole bunch of cool things as well. So Dr. McMillan knows a lot about the faculty in ABE and this environmental ecological sciences and engineering program. There's another group here, the Lyles School of Civil Engineering, which does environmental engineering and has faculty there that do water quality stuff. Division of Environmental and Ecological Engineering, or the EEE program, also does environmental ecological stuff. And so there's multiple pathways that you can enter Purdue University to do water quality type work. So you're looking at 3 of probably about 80 people that have touched water quality in some way, shape, or form.
I'll put a few of those links in the chat.
Oh, that'd be great, yeah. So we didn't have anything formally prepared, like a seminar because we didn't want to bore you. We wanted to kind of answer your questions that you have about water quality in graduate school. So feel free to post in the chat your questions. And while you're typing, I'll just say many of you, Spokane, Washington, Puerto Rico, Arizona, the Midwest, Davis, California, North Carolina. Many of you probably are very familiar with water quality issues in your respective parts of the country and nation. So we're working on a lot of those at Purdue.
I would also say that we do have a fair bit of global work done by many of us. While, both all three of us kind of talked broadly about our research interests and our content, our application is not just Indiana, not just the Midwest, not just the US. Many of us work across emerging economies across the world. And so if that's your passion, that's something that you can get a really solid understanding in the engineering principles, as well as apply it in a context that you are passionate about, which I think is a really unique and amazing opportunity at Purdue, because we do have such a wide range of faculty who do really great work across a bunch of different contexts. And there's a question in the chat: is there research being done on direct potable reuse? I'm going to assume that's a Dr. Welton question, maybe.
So there is some work that has been done previously on water reuse at Purdue, primarily by faculty with wastewater expertise, but in drinking water expertise. And the people that you would talk to about that, that I know of, would be Professor Ernest Blatchley and Professor Zhou, Zhou. Those are two people that either are doing it or would know people at Purdue University that are doing that type of work.
Just to add, sorry, that, direct potable reuse is not so common, just because it's really hard to convince people to drink water effluent. But if you can come to grad school and try to figure out some way to do that, that would be awesome. Mostly it's indirect. I think Singapore does it a little, but in the States, it's not that common. Yeah. I think there's some public perception issues there.
Yeah.
Anyway,
there's a question there, Dr. McMillan, about hydrology, soil and water hydrology.
All right. So there are a number of faculty in my department in ADE, as well as that are affiliated with environmental or ecological sciences and engineering, who maybe are not in engineering but work across engineering disciplines on soil and water hydrology. So a lot of my work kind of takes small-ish scale things, so site to riparian scales. I work a lot on water quality issues at the land-water interface. So think restored floodplains, wetlands, things like that. So that's definitely squarely in the soil and water hydrology space. But we work with faculty across agronomy and earth, atmospheric, and planetary sciences. Some names that come to mind are Laura Bowling in agronomy, who is an engineering who has an engineering degree, works in agronomy, and has joint appointment in our department, works on water resources issues. Keith Turkauer works a lot on integrating soil, water, shed, scale processes to climate change. Margaret Gitau and Jane Frankenberger both work on agricultural water quality and water issues related primarily to agriculture and drainage that we use ubiquitously throughout the agricultural Midwest. So there's a couple names. And as far as like the geospatial applications, there's a lot of great work connecting a lot of what we do in traditional modeling approaches to using remote sensing to either maybe identify vegetation types, really look at at modeling kinds of crop growth or plant growth in spaces where we don't have good data. So I'm working on a project right now to do that in Peru, where we're linking irrigation in a very, very dry desert climate and using geospatial tools to help us understand what kind of crops are grown and when. So there's a number of things. So if you're have a question about any of those specific things, you can certainly hit me up in the chat and I can connect you with some folks or talk with you more myself as well. And then I might just follow up with that international question. I would say international development is a key area that many students are really passionate about. And oftentimes what that can look like is an application that both works in a developing country and potentially, you know, development of a technology here in the US that can be used. So Dr. Welton mentioned Dr. Blatchley, who's worked a lot in drinking water applications in developing countries. We have a large group of us working in Peru right now on a whole host of ranges related to water quality and water quantity issues in Peru. So there's a lot of opportunities to do so, some on the side of technology development and some more on the landscape soil water side. But both of those can be really, really great opportunities for students to participate in.
I think the last question on the chat is interesting, but I can, I guess, first address the work with PFAS and then get to that one. But I think all of us might have some opinions about the last question. So PFAS are actually a really interesting group of contaminants that have sort of been around for decades, but has really sort of gained traction in terms of their health effects and contamination across a wide array of sectors. You know, they're actually called, they're a group of compounds. The acronym stands for perfluorinated alkyl substances. And basically they're a long carbon chain with a lot of fluorine on them. But what makes them really interesting, sorry. What really makes them interesting is that they're super recalcitrant. So if you try to degrade them, it's really, really, really hard. And so they kind of stick around everywhere. And a large problem is actually in the oceans where, I don't know if you've really seen some of the science there. It's like plastics everywhere. So my work particularly is focused on, I was doing this in collaboration with another faculty member in Chicago, and he was very much interested in looking at electrochemical ways to destroy PFAS. And so that was pretty cool. I mean, he uses these nice electrochemical cells and basically just bombard these compounds with electrons. And I think his ability to degrade these compounds is pretty robust and efficient, and some really interesting applications to try to move the technology up and make it sort of scale it up. But I would say as a field as a whole, there's really a lot of people working in this area, especially since they're so hard to remove and they're collecting in people's bodies. You know, when you use Teflon, for example, if you have a Teflon pan and you're cooking with that, you're going to get exposed to PFAS compounds. And so it's just kind of everywhere, and you probably have some in your body right now. And so right now is really a cool area to learn about where these compounds are in the environment. And also there's quite a bit of science about their health effects that are sort of emerging. So I would say this is a pretty hot area. If you're interested, yeah, please let me know. I can always link you up with some other people. There's a really well-known professor here who works on PFAS quite a bit. Her name is Linda Lee, and she's in agronomy. And so she's really excited to talk about PFAS work, and she does a lot of stuff in the subsurface, you know, basically doing, using iron, for example, to reduce these compounds, and using all these cool catalytic techniques. So definitely try to link up with her. Her last name is Lee. I can also send you that link. But then yeah, feel free to talk to her or anybody else in environmental engineering about this one topic. And I guess I'll transition to, are there interdisciplinary projects between water quality research and chemical engineering? Should I focus on a specific program to apply to or a specific topic of study? Goodness, I mean, in my opinion, and I think I'll also let Dr. Welton and Dr. McMillan put some thoughts into this, but you know, just go where your interests lie. If it overlaps with chemical engineering, great, so be it. If not, it's okay too. I mean, all of these names are sort of just boundaries, and you do whatever innovative science you think is exciting to you. I did have a chemical engineering background, but of course, you know, I'm in a different department now. So it really doesn't matter too much. Just do what you think is fascinating. And specific programs to apply to, specific topics of study. I mean, you know, every different program has sort of their different vision of where they're trying to go. Yeah, I mean, environmental engineering is probably quite different from environmental ESE. I can't remember the acronym right now. Environmental science?
Ecological sciences and engineering.
Thank you. Ecological.
Okay. There's a lot of E's and S's and engineerings
floating around. Yeah. So, I mean, I think Dr. McMillan will have a better sense of ESE, but from the environmental, you know, the environmental engineering side, I think we are quite interdisciplinary. You know, we really just want to make the environment better, and whether through engineering applications. And so whatever we need to do to link everything together and make it work, we're going to do it. So, you know, it really spans a broad range of disciplines, all the way from ABE to industrial engineering to, you know, forest management, all the way to, you know, sanitation. So there's some really interesting problems that really require interdisciplinary work. So I would say that's kind of where our whole field is going to, always trying to bring people together. But I will let the other two talk. I think maybe they have other opinions and maybe there's other questions. Yeah.
Oh, this is Andy. So I would say, as far as like along the lines of what Professor Shah was saying, is there any, what type of project should you try to apply for? So for a master's degree, it's a 2-year project, right? Typically 2-year activity. So you're not doing a 6-year commitment or a 4-year commitment. It's a project generally that has to be done, but you're not becoming the expert at that one thing. You're becoming aware of it. You're going to have a deeper understanding about an issue, but you're not becoming like the world's expert on that topic. So there's really less, you might dabble in something and participate in getting a master's in a topic that you think is interesting. Then after 2 years, you may say, yeah, no, I'm good. I think I need a different change. And that's okay. For PhDs or doctoral degrees, you kind of really need to know what you're going to do, because the doctoral degree program really everywhere can be difficult in that there is some support for how you go through the program, but it really depends upon what you want and what the people you're working with want too. And so it's really more free form, but also that can pose challenges to, your commitment. How committed are you to get through it? And so really apply to things that you are interested in. And if you don't know if you want to do a PhD, consider doing a master's. But if you definitely know you want to do a PhD, find the right fit. And what I mean by that is make sure that you talk to the people that you want to work with. you know, that really helps in the process, because generally some programs don't accept PhD students unless there's an agreement that the PhD student will be funded through the duration of their degree. And so you can have amazing credentials and amazing backgrounds, but if there is nobody in your corner helping you in committing to making sure that, you know, you're supported for 4 years or 5 years or 3 years, then that can be inhibiting your ability to basically be accepted in the program and get funding. So I would just say that there's a lot of cool things and a lot of good work that's being conducted. And then sometimes faculty land grants that they didn't expect to land, and they actually need students at times when they didn't expect to need them. So somebody in another session said, should I apply in January or should I wait until fall? Most of the fellowships that are offered by the universities are issued in the fall, but sometimes they can show up in the spring by chance. So something else to consider. If you're interested, talk to the faculty that you think you might want to work with, and they might be able to help you navigate that process. So I'll stop talking now.
I think those are all great comments. I really don't have a whole lot to add. I would just encourage everyone to do a little homework on the research topics of the department, rather than and the faculty in that department, the kinds of projects they're currently doing, kind of the work of their graduate students. As a graduate student, you're not, as an undergraduate, right, you're applying to a school. You're applying to Purdue or UNC, my alma mater, or somewhere else because of the reputation of the school, because of the things you like about the school. As a graduate student, you are applying to work with a professor, unless you're doing like a course-only master's, which is a little bit different, but I think we're talking about research here, right? And so really focusing on their program and what it is that you kind of connect with, I think is really critical as a graduate student. Ask lots of questions of that particular person. Try, if you can, to talk to their graduate students. They often are the most useful kind of conduit into what it's like to be that particular professor's grad student every day. You get a sense of the culture of their lab, how big it is, how they manage it, you know, those kinds of things. So I really think it's all those things that Dr. Shaw and Welton said are really important. And I just would encourage you guys to ask lots and lots of questions as you're trying to find that right mentor. And I think it's particularly important, like Andy said, about at the PhD level compared to the master's level. PhD is kind of like setting the tone for your future. And that's where you really want to make sure that you're in a spot that you feel like you can be particularly successful for.
And I'll just jump in. So I went to master's. I pursued a master's degree because I couldn't get a job. And actually, I didn't get funded for my master's degree either. So I went to graduate school begrudgingly. And I also said I would never be a professor ever. So after I did my master's, I said, yeah, that's about it. I'm done with school. And so I went and I got a job, and I worked for the US Army and the consulting firms, and ultimately realized that what I wanted to do, I needed a PhD. So I didn't know that I wanted to get the PhD. And my friends used to make fun of me when I went back to school, because I was like adamantly against it. So some people know what they want to do, and some people don't know what they want to do. Some people have funding to go to grad school, and some people won't. And it's just, you know, how things work out. And there's a right way for everybody. And so I would just say, do what you want to do that you can afford to do, and everything should work out as long as you have options.
I often laugh when I hear that story, because that echoes my story a lot too. I got a master's degree because I needed a job and I couldn't find one. And I went to work for a while because I thought, heck no, I am not going to grad school for that long. And then I got out there and I recognized that the things I wanted to do, I really needed more expertise. So yeah, Andy and I have a very similar path. And the nonlinear path is okay too. If that's any of you in this room, or if you're contemplating that, like I have a undergrad now who's like, was planning to go to grad school the whole time I've been her undergrad advisor. And this year she's a senior and she's like, Dr. McMillan, I just can't do it. I need to get out of here. I need a job. I'm like, great, go find your bliss and see what makes sense for you and where you really want to focus. Because there's nothing worse than going through many months and years of graduate school and not like being truly passionate, because it's hard. As you probably are expecting, it's not the easiest path, and you really want to kind of be all in, as they say. So.
Yeah. So there was a question about the building water safety work that we did.
Oh, yeah.
And to the student that asked it, yes, we tested buildings on Purdue's campus, and we tested other buildings around the country. And, you know, Purdue, we didn't really find anything, but other buildings in other places we did. Legionella contamination, high metals. And so, you know, it's a really interesting time to be, you know, working on research issues in the public health field, because there's so many things being thrown at society today that's affecting everybody indiscriminately. So whether you take your kids to daycare and they get water, or, you know, hospital, or, you know, long-term care facilities, I mean, all sorts of different aspects of society now are kind of honing in on the value of public health and what that is, and whether or not that can help answer questions. So it's a really interesting time to be involved in science and engineering. And with that, there's potentially some opportunities. Faculty may have some funding agencies may have some. So there is ways sometimes that you can get funded by an institution to go to a graduate school. And so there's just many different ways to get into graduate school. There was a question about Linda Lee's work. Can anybody answer that?
Sorry, I tried to. Is this related to?
Oh, there you go. Okay. Yep.
Okay.
Yeah. Okay.
Well, but I mean, I can also extend on that. I mean, yeah. I mean, I think she does a lot of different things, you know. PFAS is primarily her interest as the last a few years have gone by, but, you know, really luckily for us, there's so many contaminants in groundwater and soil. So she is, you know, I'm probably sure she'll be interested in any sort of emerging contaminant that would be present in those systems, and any cool technologies that you could think up perhaps to treat those in a cost-effective, simple manner. So yeah, there's nothing to really say that, yeah, I think this probably speaks to all of us. We don't really necessarily, or we're not pigeonholed to any specific area. I mean, we all kind of go about our way and do the things that come up that are kind of cool, that just spark our interest. And so any new paper that you guys find that you think we would also be interested in, or any cool idea, you know, you should always feel free to talk to anybody about any cool idea that you think you have or want to explore further. I mean, most of us are pretty open to all of that stuff. So no boundaries, in my opinion. So, yeah.
There's a couple questions about collaborations across disciplines. And yeah, to answer that question, so the way faculty work generally, it doesn't matter the institution, is you teach, you help educate, you train students, and so they can get good jobs and lead the careers that they want to lead. But you also do research, and the research is discovery-based generally, where you are looking to address problems that exist, find new problems that nobody can kind of figure out what they are. And through that, nothing is siloed, right? Like, and you might look at us and say, well, you know, Dr. Shah is environmental engineering, I'm in environmental engineering, and Dr. McMillan's an environmental engineer too. So you're hearing from one group, but really we work with people all the time. I mean, I've worked with pulmonary toxicologists and bench scale chemists who create new chemicals that have never been created before, plastics engineers, risk assessors, people that do health risk assessments. And I'm sure they might want to like name off a few types of disciplines that you've worked with.
Sure. I work across maybe more with ecologists and scientists. And there was someone who said geospatial analysts. So I work a lot with like people who do some really cool data science stuff, sensor development and deployment. I also work a lot with social scientists. I would say a big chunk of my research program right now is extending the work we do as engineers to the social ecological context. So how are disadvantaged groups affected by things like environmental justice and disparities in not only just housing and all kinds of services that are being used and applied in urban areas, but across the rural Midwest as well. So I would say, yeah, lots and lots of collaborative work is done across all of our disciplines. And the days of a single investigator grant, at least in the environmental space, I think are largely gone. I don't know if there's certainly some like niche little, like I got the coolest tech for this particular thing, but I would say much of the big things that we are working on these days are very cross-disciplinary. One good example is if you scroll up in the chat, I did put a couple links in there, and one is about the Purdue Nexus. So it's kind of stuck after Linda Lee's article about her PFAS grant. But that is a really great example of folks from a bunch of engineering science, social science, economics, building, construction, all kinds of disciplines coming together.
So Dr. Shah?
I think we're all students at heart, honestly. Like we're still students at heart and we always want to learn new things, and learning new areas and collaborating with them is super exciting. So of course, I primarily collaborate with probably more in the chemistry space, I would say, because that's kind of where I also wish I did more work, synthetic chemists, analytical chemists. I think there's a lot of interesting sort of applications between environmental engineering and, fundamental chemistry. But anybody else in, agronomy, certainly, it's hard to even, chemical engineering as well. I mean, yeah, really anything and everything that kind of connects engineering to environmental systems is something that I would be interested in doing. So collaboration's kind of across the board, I would say. Not necessarily just in engineering for sure, but sciences as well. So. And
from like water quality perspectives, I know some faculty work with nurses. They go overseas with nurses and multidisciplinary teams of nurses, and they're the water quality expert, and the nurse is public health expert, right? And there's other economics and political science, and so really graduate school. Look for graduate schools that the master's programs support really what you're interested in. And, the PhD program should support what you want to be for the first part of your career. And so, that's what I would recommend, because water quality is a huge issue. Natural waters, drinking waters, water reuse, direct potable, I mean, all sorts of things. And so it's wide open. You can do really anything in the space.
I want to just underscore that, because I think so much of why we get into this field is we have this drive and passion to basically save the planet or save the world or save the population, various kinds of environmental ethos in this space. But the key thing as a graduate, then that's important as a grad student, right? To work in a place where you feel really passionate about the issues. But I also think it's really important to build those foundational building blocks for your core science. For example, I work on microbiology in these different kinds of natural contexts now. But as an undergrad and as an early master student, I learned about microbiology and wastewater treatment plants. So understanding the fundamentals and really, how do you get that knowledge ingrained into your toolbox, if you will, I think it really helps you as you move forward. So I had a short private conversation about someone wanting to work in global issues and how challenging that is right now in the context of COVID, because none of us can really travel. And so while that might be your passion and that might be where you apply your expertise after COVID, because there will be an after COVID in theory, I'm hopeful. I think we all are very hopeful for that. Building those skills that you can apply there in a context that you can get to maybe now is a good way to start. So trying not to be too discouraged if you're really wanting to do field work and you're really wanting to go into places that you're not able to go.
And just to kind of, so a little perspective, there are some things that just won't happen during a COVID pandemic, but there's other things that can happen. So we did field work out at elementary school that turned out to have Legionella, and they needed to get restarted. There's other sampling campaigns that can go along. And for people that don't want to do field work or lab work, there's mathematical modeling, there's other policy analysis, there's other aspects of water quality that you can do. You just need to find the right the right fit, where you want to be and who you want to be working with, and everything will work out in that sense.
Sorry, just as I'm going through the list of questions, I just want to make sure that we hit this one. This is more technical, I think. Is the GRE waived for Purdue students, or do we have to take it? Since I don't know the answer to that question, maybe someone else does. But I think you can easily ask someone in Purdue admin.
I will say one quick thing, because I've been involved in many of these conversations, as I'm sure you both have. ESC does not require the GRE right now. I don't know about other departments in engineering, but many schools, both at Purdue and elsewhere, are waiving the GRE. And I think the particular question was, if you are a current Purdue student, that might be another little nuance that I don't know. But there is certainly a movement for folks to move away from GREs. And I know that there are many departments and schools at Purdue that do not require it, some that still do, and many universities around the country that do not. So
with regards to applications, for those of you that have no experience in water quality, that's okay. For those of you that do have experience, just make clear the role and extent of the experience you have, and don't assume that somebody will figure it out if you don't mention it in your resume or application package. For those of you that don't have any experience, underscore what has influenced your decision to do something. Because generally when it comes down to funding students, funding generally comes from projects that exist or initiatives that exist. And that means that the student would then directly support that initiative. And generally people hire or offer those who have the most promise to help advance that initiative directly, or can be trained and support it. And so in terms of funding wise, for competition, just make sure that you underscore your experience and motivation and drive and why you want to do what you want to do.
Do we have any other questions for our panelists?
there's another one in the chat from Elizabeth. That's a great question. I wish it wasn't asked at the very end, but we'll try to do our best in the 30 seconds. Andy, do you want to go ahead?
So I've been at Purdue for 6 years, and students have ended up in industry. They've been in academia, and they've gone into consulting. So it's really all over the board. And some students that came from other countries went to other countries after coming to the U.S., and others stayed in the U.S. and such. So it's really all over the place.
I just had a postdoc doing a ton of job searching. She ended up getting an extension type faculty position. So it's not it's an academia, but slightly different, working on education and extension outreach. She had opportunities at many different governmental agencies. So that's another area that a lot of our students tend to go through looking for jobs. So I think EPA is one where we often think about, but there's opportunities with Forest Service, USDA, gosh, I'm blanking on, but there's several different, and as well as nonprofit agencies too. So I think I was blown away by the number of opportunities she had, because oftentimes, you know, I think I have my own experience, but yeah, I think there are lots of great opportunities, and she was incredibly competitive with her background and her degree as well. So there's lots of options.
So for master's students, most of the students that get a master's degree in environmental engineering or civil engineering and environmental option go to industry. So they generally go to consulting firms or municipalities or for-profit manufacturing companies. So that's where ours generally go. Dr. McMillan, what about?
Mm-hmm.
Yeah.
I mean, I think you can even think outside the box, like Homeland Security is starting to do a lot of stuff with like water security. And so it doesn't necessarily have to be like the traditional paths that you usually think about. You know, you don't have to go work for a water utility, but like water security in developing countries or USAID, like I think, you know, you can really take your PhD and really go into some pretty interesting areas, honestly, that are not necessarily so traditional, but I think are really critical to, safety and security and things like that.
As far as getting jobs, right? For the students, you know, they want to participate in meetings during their graduate degree, whether they be professional conferences or meetings, online meetings, or just basically finding ways to meet people so that the next jump to the next location will be easier. They will have opportunities. So students should pay attention to that. You know, are students given the opportunity to engage with industry? Can students take initiative and go to meetings, regional or national or international? And then does the group that they're working with support that? Or, you know, are they kind of on their own? I mean, that's something that I would use as a metric to differentiate where I might go.
Okay, I think the time is up for this session, and we do appreciate you all for being here.
Well, thanks to everybody who came in and asked questions and told us where you're from. Pretty awesome.
Thank you so much, everyone. It's been a pleasure. And if there's any additional, we are very easy to find. You can Google each of our names, Purdue, and there's no shortage of ways to reach us. So please follow up if you have more questions.
Everybody email Sarah.
Thanks, Amisha.
No problem.
Have a great day.
Yeah.